All right, in this video, we're simplifying complex fractions. And what we're going to do then is simply to multiply every fraction that makes up the complex fraction by the LCD for all the fractions in the complex fraction. So what I need to do first is find the LCD. Normally you would factor to do that. So in problem A, we don't have to factor because it looks like these denominators are already pretty simple. We have 2 over 1, 1 over 1, and then we have 2 over x and 2 over x. So the LCD for the overall fraction here is simply x. So we'll multiply every numerator for each fraction by that LCD. So I'm going to put an x up here, an x up here, an x up here, and an x up here. That way every fraction has that LCD multiplied in the numerator. So for the first product, we're going to end up with just 2x. And then for the second fraction, the x here will cancel with the x there, leaving you minus 2. Then we'll have our fraction bar. We'll have 1x, or just x, plus, again, the x's will cancel, giving you just 2. Now from there, we could simplify by trying to factor out the common 2 in the numerator. That'll give you x minus 1, and that will be over the denominator, x plus 2. We can't do any more to this because we don't have any common terms that we can cancel, so we'll just leave that alone. And that's our answer. Let's look at example B now. For example B, we have a similar setup. We're going to find the LCD for the entire fraction. I think the least common denominator here would be x squared, because remember, we take a representative of each factor we find in the denominator, and then we take it to the highest power. So the only thing we see in the denominators here is essentially the number 1 or the variable x, and the highest power for that variable is 2, so we'll take that as our least common denominator. Now we need to multiply every fraction in the numerator by that LCD. So I'm going to multiply x squared times this fraction, x squared times this fraction, x squared times this fraction, and x squared times that number 1. Okay, so x squared times x is just going to give you x to the third. Then we'll have minus. The x in the denominator here will cancel with one of the x's in the numerator there, just giving you minus x. Draw your fraction bar. The x squared in this first fraction will cancel out with the x squared in the denominator, just leaving you 1. And then we'll have minus 1 times x squared, which of course is just x squared. Now from here we want to try to simplify, so we'll factor out the common factor in the numerator. That'll be x, and that'll leave us with x squared minus 1. And then in the denominator we have 1 minus x squared. Let me rewrite that as negative x squared plus 1. All I did was switch the positioning of the terms. And then I can factor out a negative 1, I believe, from the denominator. So we'll have x times x squared minus 1. And then I'm going to pull out a negative 1. So I'll put a negative 1 out here. Negative 1 divided into negative x squared is going to give you positive x squared, and then I'll have negative 1 after that. Now at this point you can see that these two pieces will cancel out, and then we have x over negative 1, which is just negative x. Alright, so let's look at the last example, example C here. So the LCD here is a little more involved. Remember, this h is h over 1, so it has a denominator of just 1. That means the LCD for the overall fraction then is going to be this factor, x plus h quantity squared, and x squared multiplied together. So that's your LCD. We need to multiply every fraction in the complex fraction by that denominator. So I'm just going to pen in here x squared times x plus h quantity squared for the first fraction. Do the same for the second, x squared, then x plus h quantity squared, and then lastly x squared times x plus h quantity squared. Remember, those go in the numerator always. All right, so let's cancel what can be canceled. So the x plus h squared cancels with the x plus h squared, leaving you just 1 times x squared. Then we'll have minus. The x squared here will cancel with that x squared, giving you negative 1 times x plus h quantity squared. All of that will be over h times x squared times x plus h quantity squared. All right, for this one, you might be tempted to expand out this squared binomial here. But I would argue that that's a squared term. In other words, if I rewrote that as simply x squared minus parenthesis x plus h quantity squared, you might notice more clearly that that's a difference of two things that are squared. And the reason why that is helpful is because that means we can factor it by just splitting it up into basically x minus x plus h without the square on it, and then x plus h without the square on it, right? So I just take the root of both of the things that are squared. Okay, and then we have in the denominator x times x squared times x plus h squared. All right, now why is that helpful? Because you'll notice now the insides will simplify because we can just distribute in this negative here across the pieces, giving you in that parenthesis x minus h. And the second parenthesis, it'll just be x plus h. All over that denominator, hx squared times x plus h quantity squared. Now from here, negative x and x cancel out, leaving you just negative h times, here we have 2x plus h. All over h times x squared times x plus h quantity squared. So I can cancel out the h's now, and I just have negative 2x, if I distribute in this negative 1, minus h, all over x squared times x plus h quantity squared. And that's it. That's all we can do.